Hey everyone, welcome back to my YouTube channel. Today we're solving another Leet Code challenge, Leet Code 6 Zigzag conversion. We'll be given a string which we have to print in a zigzag fashion and then read it line by line and return the resulting string. For this one, I'll be using two different approaches to solve the problem. You can follow me through both the approaches and then decide which one works better for you. Let's get started. In the zigzag conversion problem, we'll be given a string, let's say think different, and then we'll also be given number of rows in which the zigzag will be. So if the number of rows is 3, then think different will be written something like this. THI, then NK, DI, FFERENT. So this is the zigzag pattern. Similarly, if the number of rows is 4, then think different will be written like THIN KDI FFERENT. Now, the first approach that we'll be using to solve this problem is to simply store this value in a 2D array and then use that 2D array to print the output. Let's see how we can do that. Say I have a 2D array of size equals to number of rows. That's the one direction of that 2D array. Say 3. And I'll be iterating on rows and columns for this array. So let's say initially row is 0 and column is 0. And I'll keep incrementing the row. Okay. So with row 0 and column 0, I'll put the first alphabet of the string into the 0, 0 position. So I get T here, then row will become 1, C will stay 0, and I'll get H here, then row will become 2, C is going to stay 0, I'll put I here. Now I've reached the last row. Then we can put a condition in place that if row is equals to number of rows minus 1, then you flip this direction. So now we'll start decrementing the row. As we are decrementing the row, we'll also increment the column to give it a diagonal shape. So when you're decrementing the row, column will increment. And when you're incrementing the row, column will stay as it is. So now my row is equals to num rows minus 1, which is the last row. I'll start decrementing the row. So row becomes 1. I'll put n here. Then row becomes 0. And here column also becomes 1 because we're incrementing the column. Row becomes 0, column becomes 2. I'll put k here. Now comes in the other condition. If row is equals to 0, then we'll start incrementing the row again and will not do anything to the column. So now the same cycle will repeat. I'll get D here and I here. Then row will again be equal to num rows minus 1. So I'll start decrementing the rows and incrementing the column. I'll get F here and F here. Then row becomes 0. You start incrementing the row, the column stays static, and you get the complete string. And now to print the output, which is this zigzag string read line by line. So TKFN HNDFEETIIR. So we can do that if I just complete this. So we can do that by reading one row of this array. So if I read the first row and the second row and then the third row, I'll get the desired output. We can try a very similar approach with number of rows 4 just to prove our point. So say in here also I have a 2D array of size 4. Okay, I'll start with row 0 and column 0. And initially I'll keep incrementing the rows, column will stay static. So at row 0 in column 0, I'll put the first alphabet, which is T. then row becomes 1, column stays 0. I'll put h at that location. Row becomes 2, column stays 0. I put I. Row becomes 3, column stays 0. I put n. And now the condition is met that r is equals to number of rows minus 1. When we reach the last row, we start decreasing the value of r and increase the value of c. So in that case, r will become 2, c will become 1. And I'll put k here, 2, 1. R will become 1, C will become 2. I'll put D here. And R will become 0, C will become 3. I'll put I here. Then I've reached the other endpoint. So the conditions will flip. If row is 0, I'll start incrementing R and column will stay static. And I'll get F, F, E, R, E, and T here. And again, to get to the output, we can just read this array row by row and we'll get the output. So this is a very simple approach using a 2D array. Let's try to code it. So with the matrix approach, we'll be using a 2D array to store the results of each row. And let's start with the basics. We'll first check if the number of rows is 1. In that case, just return the string, because if it's just one row, then the zigzag pattern will be the same as the original string. Otherwise, we'll create a matrix which we can initialize as a blank array. Then I can iterate till the number of rows. So index from 0 till index is less than number of rows. And in here, I'll simply set that index of the matrix to another array so that we get a 2-dimensional array. With our storage area ready, we can proceed with reading the string. For that, I can create another loop. Again, starting from 0, and this time the index will go till the length of our input string. Along with the index, I also need a counter for which row and column the program is currently at. So I'll just take a row starting at 0 and a column. And when I'm in this loop, I'll simply set for that matrix, set the row and column index. So set that position to the current value of our string s, which will be index position of s. Then I can make a condition because I have to check whether I'm going down the rows or I'm moving up the rows. And for that, if my row counter is equals to number of rows minus 1, that means I've reached the last row, and I'll need a Boolean flag also. Let's say row increment, which will initially be true because when we'll start with our algorithm, we'll be starting from top going to the bottom, incrementing each row. So row increment equals true. Then if we have reached last row, we'll set row increment to false. On the flip side, when we are decrementing the rows, if our row counter comes at 0, which will be if reached the first row, then we can again set the row to increment instead of decrement. Okay. Then comes our row and column shifting, as we discussed. So if we are incrementing the row, we'll simply set row equals row plus 1. Otherwise, which means when we are decrementing the row, that means we're going up, we'll set row equals row minus 1. Also, as we go up diagonally, we'll set column equals column plus 1. So when we go down straight, but when we come up diagonally to match that V structure. So that's the simple loop, checking for the increment, and then based on whether it's increment or decrement, changing the value of row and column. And then after this loop, let's try logging the value of the matrix to the console. So if we run this, so for this input, PayPal is hiring and number of rows 3, which is this zigzag pattern. We can see in the first array I got PAHN. In the second array I got APLSIIG, which matches with this. And then in the third array I have YIR. Similarly, we can check for this input, case 2. So in the first row I've got PIN, and then there are some empty items which we'll get rid of in a bit. Then ALSIG, YAHR, PI. So that approach is working as expected. Now once we are done creating our matrix, I can simply keep a output variable which will be an empty string, and then I'll again iterate on the number of rows, which is the size of my matrix. And then for each row, I'll just append that row to the output. So output plus equals matrix index, which means the first 1D array, first, second, third, but selecting the complete 1D array at once. Then I can just use the join function to join it using empty string so that it all gets concatenated. And in here, I can just return the output. Before returning, let's just log it, then we'll submit it. Expected PAHNA, PLSSI, SIIGY, IR, and that's the output. So I'll just get rid of console logs and return the output from here. Okay, with that, let's submit it. Okay, that passed all the test cases, and we got 202 millisecond in runtime, and it used 57 MBs of memory. Now we'll just compare it with the other approach. Now with the pattern-based approach, instead of saving some intermediate values in arrays, we'll try to think if there's a way I can make the right number of jumps, I can skip the right number of characters and get this output from this input itself. Like, what will it take if we take numRows 4 as an example? What will it take to go from T to I and then from I to N, so that I can print this character, then this character, so I can print this character and then this character and then this character without saving it anywhere. And to be able to do that, let's see how many jumps we need to go from one character to the next in any given row. So say if I'm at T and I have to go to K, I need 1, 2, 3, 4 jumps, and my fourth character is the one that I need. Similarly, to go from K to F, I need 1, 2, 3, 4 jumps, and my fourth character is F. So for number of rows equals to 3, we can say we need 4 jumps to get to the next character. Similarly, with number of rows equals to 4, if I have to print just the first row, say I'm at the first character T, then I can skip or jump 1, 2, 3, 4, 5, 6 characters, and then my sixth character is I. Then when I'm at I can jump 1, 2, 3, 4, 5, 6 characters and I'll get N. So we can say with numRows equals to 4, the jumps that we need is 6. Similarly, we can take it to numRows 5. If I'm at T, I want to get to F directly so that I can just print it without saving it anywhere. I'll need 1, 2, 3, 4, 5, 6, 7, 8 jumps, and my 8th character is F. So we can say with numRows 5, the jumps is 8. And we see a very simple pattern here, that the jumps is actually equal to number of rows minus 1 multiplied by 2. So if number of rows is 4, You get 3 into 2, 6. If number of rows is 5, you get 4 into 2, 8. And that's the number of jumps you have to make to get to the next character. And this is true for any given character in this pattern. So if I'm at H, I make 1, 2, 3, 4, 5, 6 jumps and I get F. Similarly, if I'm at N, I make 1, 2, 3, 4, 5, 6 jumps and I'll get to E, so that I can just directly print it. Now, this static jump of num rows minus 1 multiplied by 2 is valid for the first row and for the last row. But for all the rows in between, we see that the number of characters that are getting printed are double. Okay, because it's a V kind of a structure. So at the top we have one element and at the bottom we have one element, but then for all the values in between there are two elements each. Okay, let's simplify that. So if I'm at the second row, say I'm at H, and if I use this jump, so I'm at H, I make 1, 2, 3, 4, 5, 6 jumps and I get to F. But what did I miss? I missed the D that is needed. So for the intermediate rows, we'll pick two characters and we'll just tweak the jump a bit. So this jump will anyways help me in getting from H to F and then from F to T. But the question is, how can I get from H to D and then F to E? And for that, we'll see that the pattern is, if I have to get from H to D, again, let's see how many skips do I have to make. So 1, 2, 3, and then fourth character is the one that I need. So we can say small jump equals 4. Okay, and similarly, if I'm at I and I have to get to K, then I make just 1 and then second character is K. So small jump becomes 2 here. So the number of jumps that I'm doing is actually decreasing as the number of rows are increasing. And that makes total sense because the diagonal value is decreasing as we are going down the rows because it's a V-shaped structure. So the number of jumps that I'll have to make will be less as we go down. So to get from H to D, I had to make 4 jumps. To go from I to K, I had to make 2 jumps. Let's try the same thing here. I know to get from H to E, I need 8 jumps. But then to get from H to F, what is the number of jumps needed? That's 1, 2, 3, 4, 5, 6 is the element. So from H to F, 6 jumps. From I to I, if we see, 1, 2, 3, 4th is the character. So I get 4 jumps. And then from N to D, again, it's just 2 jumps. And then again, it's a row-based pattern here, that the number of jumps needed for that second character for all the rows other than the first and last rows becomes, so we can say small jump will be, and if we compare it to the actual jump, so that's 6 minus 2 and this is 6 minus 4. And let's look at this value here, 2 and 4. How we can get that? That's simply jumps and we'll subtract your row counter multiplied by 2. Like here, row 0, 1, 2, 3. When we were at first row, the jumps were 6, but we jumped 4, which is 6 minus 2 to get to D. 1, 2, 3, 4th we got to D. And if I'm at row 2, then 6 minus 2 into 2, which gives me 2. So I just made 2 jumps to get to K. So that makes sense. To pick the second character, I have to make a little smaller jump. so that instead of directly going from H to F, I'll first go to D, and then I know how to go to F with my normal jump. Now we'll just use these two jumps to iterate on this complete array, and we'll keep printing each value as we jump through the string. Let's code it up now. For the mathematical approach, the starting stays the same, that if number of rows is 1, you return the original string. And then I can iterate on each row and then print the right characters for that row. So if I'm at row 0, I'll just print P, I, and N, and so on. For that, let's create a loop, say row counter starting from 0 till the row counter is less than number of rows, increment row by 1. And then for each row, I need to know the jump needed. And we now know the formula for that. So let's say the increment needed is number of rows minus 1 into 2. So here the number of rows is 4. That means we have to pick every sixth character. 4 minus 1, 3 into 2. So first I'll pick P, then I, then N. If I'm at row second, I'll pick A and then S and then G to get the right characters. Then I can have a simple loop for index, which can start from my row counter, and it will go till the length of our input string, and will not increment the index by 1, but will actually make it jump according to the increment. So index equals index plus the increment. Once we have that, I can keep an output variable initialized as an empty string, and then in here I'll simply add to the output the value of string at the index. So let's see what we get after this. So when we run this, if we look at case 2 where the input string is PayPal is hiring and the number of rows is 4, in the standard output we get PIN, then ASG, YH and PI, which matches with PIN and then ASG, then YH and PI. So we talked about that this works for the first row and the last row, but for all the rows in between, we have to pick two elements at each instance. So like once I'm printing A, I also have to print L. If I'm printing S, I also have to print I. Similarly here, if I'm printing Y, I have to print A also. And for that, we'll simply make a condition that if our row counter is not 0, that means if it's not the first row, and row counter is not equals number of rows minus 1, if it's not the last row either, and we'll put one more check here, but let's see what we'll do in that case. We'll simply set output equals to, from our string, we'll take index plus increment. We know that that will give us this character. If I'm at A, that's going to give me S, but what we need is L. If I'm at Y, index plus increment will give me H, but what I need is A. So I am coming back a few steps. Like here, from A, I'm going to S with 6 jumps, but I'm going to L with 1, 2, 3, 4 jumps. So I'm coming back 2 steps, and for that, I'll just subtract 2 into, not the number of rows, the row counter. Because the number of jumps that we have to take back actually decreases as the number of rows increases, which we can see here because it's a V kind of a structure. So that becomes our output. Also, the condition that we have to add here is, for example, if I'm at S, I know I can pick up I because our string has that position. But if I'm at G, there's nothing after it. So I'll have to first check if there is an element at this position. So we'll simply add that condition if this is not null. And since that is implicitly decided, so I can remove this, just put that here. Let's have a look at the output now. Okay, for case 2, if we look at the standard output, it matches. Let's just return the output. Okay, I'll just submit it now. So with this one, we can see the runtime has come down to only 84 milliseconds, which beats 96% of the users. And we also consumed less memory than before. Here is a quick side-by-side comparison of the runtime and memory usage of both the approaches. So with the pattern-based approach, the runtime was only 84 milliseconds, and with the array-based approach, it was 202 milliseconds. And that is because with the array-based approach, we spent time in populating that array and then reading it and then joining it all together to get the output string. But in case of the pattern approach, we just made the right jumps and just printed the pattern right away. Similarly, in terms of memory, with the array-based approach, we used 57 MBs of memory because we were saving the intermediate rows in different arrays in our 2D array. But in case of the pattern-based approach, we did not use those arrays, so we used less memory. I hope you were able to follow me along in both the approaches and can now use them to solve the zigzag problem yourself. If you liked the video, please share it with your friends and subscribe to the channel for more learning content. I'll see you in the next one. Peace out.